Hey, it's your tutor Courtney Waterman, lover of anime, manga, and math. And this is another session of Tutor Me Senpai. Welcome back, everyone. Today we're jumping into an 11th grade topic, factoring the sum of perfect cubes as well as factoring the difference of perfect cubes. If you have any questions about what you see here today, feel free to put them in the comment box below. If you have any questions about your own homework you'd like to see on this channel, remember you can always visit me on Facebook at Tutor Me Senpai and tell me all about it there. If you find this video helpful, remember to leave a like. It really helps the channel. And while you're at it, hit the notification bell and smash the subscribe button so you know exactly when I drop my next videos. Well, without further ado, let's talk a little bit more about factoring the sums and differences of perfect cubes. Now, the first thing I want you to realize when I say factoring the sum and differences of perfect cubes, what I mean by that is if you had a number, let's say 2, and you cubed it, what do you get? Well, in this case, you get 8. So 8 would be what I call a perfect cube because it is just 2 times 2 times 2, or 2 cubed. So when you have something that has a cube root that you can easily find, then we consider that a perfect cube. 9 is not a perfect cube because there's nothing that when you have x cubed will equal 9. So because you can't get this, 9 is not a perfect cubed. So 8 is because 2, whenever you cube it, gives you 8. 9 would not be a perfect cube because you don't have anything when multiplied by itself 3 times will give you 9. So now that we talked about what a perfect cube is, let's talk about these sums and differences of perfect cubes. So now you have a cubed plus b cubed. So in both of these situations, they're perfect cubes, right? Because whenever you cube a, you get this a cubed, and whenever you cube b, you get this b cubed. So this would be what we call the sum of perfect cubes. Likewise, if we had a cubed minus b cubed, this would be what we call the difference of perfect cubes. Once again, the perfect cube meaning we have something when cubed give us our final result. A in this case would be cubed to give us the final result of a cubed. B would be cubed to give us a final result of b cubed. So these are both perfect cubes. And this is the sum since we have addition, and this is the difference because we have subtraction. So this is what we're referring to when we say the sum or difference of perfect cubes. This is how it's going to look. Now, in order to factor something like this, it's going to be very easy. It really just depends on you remembering a simple formula. Now, remembering that formula might be a little bit more tricky than going about the steps to use that formula, but I have something that I think will be really helpful in remembering how to set up your formula. So the two things I want you to remember are going to be SMS and SOAP. Now, you might be looking at what in the world is SMS and what is this SOAP that we're speaking of? I thought we were talking about math here. Well, this is what we're going to use to remember how to set up our formula. Now, if you can remember both of these in the exact order that you see them, you're about 90% of the way done with the factoring part of this. Let me show you what I mean by that. So we're going to have two sets of parentheses. One large set and one small set. The large set typically comes second, but you don't necessarily have to do that. You know multiplication is commutative, so you can do it either way, but we tend to write the larger one second. Next, we're going to take the cube roots of our perfect cubes and put them in the first parentheses. So because a cubed gives you a cubed, a is the cube root of a cubed. Likewise, b is the cube root of b cubed. So we're putting these in the first set of parentheses. Once we have this, now we look at SMS. Now, what does SMS stand for? This stands for square multiply square. And this tells you how you're going to fill in this second set of parentheses. So we're going to square the first cube root. So we're going to get an a squared. Then we're going to multiply these two cube roots together. So you're going to get an a times b. Then we're going to square the last cube root. So you're going to get a b squared. And you can do the same thing for the bottom. You see it looks very similar, right? There's a squared, there's ab, and this b squared. So now we filled in our two sets of parentheses. We have our ab here, we have our a squared, ab, b squared, ab, a squared, ab, b squared. So we have everything filled out, but we're missing the signs. Now at this point in time, you may think that, hey, it looks like we're going to be writing the same thing. Don't fall into that trap. This is where SOAP comes in. Similar to how SMS filled in these parentheses with the actual cube roots and, their combinations, SOAP is going to fill in these parentheses with the signs that are given to everything. So what does SOAP stand for? We know what SMS stands for, square multiply square. That's how we got this. But what does SOAP stand for? Well, SOAP stands for same, opposite, and always positive. Now I write always positive together, whereas I separated these because this is going to be together. And you'll see what I mean by that. So same, that lets us know what sign goes here. The first sign goes here, the second sign goes here, and you see this is acting as one unit, goes here. So same means, what are we doing here? Is it a sum or is it a difference? Well, because we have addition here, it's a sum, so we're going to have the same sign in here. So if you do the same thing down here, are we going to have an addition sign here? No, because this is a difference. So to keep the same sign, this is going to be a subtraction. Next, we're going to look at the opposite. Now this is the opposite of whatever we put here. So if the first sign was the same as this is going to be the opposite. So in this case, we have a subtraction. In this case, we have addition. And now this one lets you know that no matter what you have, a sum or a difference of these perfect cubes, this last one is always positive. So SOAP lets you know how to fill in your signs. The same sign as to whatever you're doing here, the opposite sign, and then this one is always positive. So these are going to be our formulas to help us factor these sums of perfect cubes and the differences of these perfect cubes. Once you have this formula and you can find your cube roots, it's just simply plug and chug. And then that's your answer. That's why I said factoring is probably going to be really easy once you have your formula. The trick is going to be, how do you remember this formula and not get it mixed up? That's where these come in. Remembering SMS and SOAP will allow you to always recreate this without having to memorize which one goes where. Now SMS might not jump out at you, and you want to make sure you keep it in this order. You don't want to ever get SMS mixed up with MSS or SSM. Like, those are different, and that's not going to give you the correct order in which these are supposed to be filled out. You have to remember it's SMS. And I'm here to help you with that. So if you're anything like me, and this is going to be completely unrelated to math necessarily, but this is how I can kind of remember this. I like to sing in the shower. And this SOAP here is making me think of a shower. So I like to put a little story to this. This looks like sing more songs, right? For me, in my head, I'm looking at this as sing more songs. That helps me keep the order of SMS without getting mixed up. And it's somewhat related to SOAP, because I like to sing in the shower. So I sing more songs while washing with soap. So if you like to sing while you're in the shower, try to remember sing more songs while washing with soap. That'll give you SMS and SOAP. Now before we jump into our question, I want to give you one more reminder. I don't want you to get so swept up in what we're doing that you forget that this is truly factoring. Whenever you're called to factor, most likely you're trying to factor down to its simplest form. So jumping straight into our type of factoring that we're doing today, while ignoring the other things that you've learned about factoring, is probably going to give you half of the answer or 3/4 of the answer, but you might not get the whole way. So don't forget the other forms of factoring. For example, let's say we have a question that looks like this. Now, this doesn't look like something we can use our sum of perfect cubes. However, if you attack this first using other methods of factoring, then you see that it actually does resemble something we can use. So the first thing you want to do is, all right, is there anything you can factor out? What's in common between these? So it would be an x, just from looking at this, right? X is common in both of these. So we're going to take out an x. But is that the only thing that's in common? No. We also have a 2 that can go into both of these, right? So we factor out a 2. So we get a 2x here, and this goes down to 8x, right? Cubed plus 27. And if you look at this now, this 8, that's a perfect cube. So is this x cubed. And so is this 27. So now you have something that we can potentially use what we're going to talk about today, our sum of perfect cubes. Whereas before, it didn't look like that. So don't forget, don't abandon those other methods of factoring, because that's probably going to help you simplify your answer even more. So to piggyback off of the example we just showed below, let's say you did have something like this, right? It might not be obvious that you can use our sum of perfect cubes because you have this 8x cubed here. However, if you take this as a whole and cube root it, what do you get? That's just going to be 2x, right? If you were to multiply 2x by itself 3 times, this right here will give you 4x squared. This will give you 8x cubed. So even if you have a product over here, you can still use that in our sum or difference of perfect cubes. I just recommend that you write everything in parentheses. So whatever the cube root is going to be, put it in parentheses and then put your cube out here. So it'll look like this. And if you want to put this in parentheses too, just to make things consistent, sure. So now you know, for your formula that has the a's and b's, a in this case would be the 2x and b would be the 3. So plugging and chugging will give you your answer. So our question for today has us looking at 125 minus x cubed. Now the first thing you want to do when you're trying to figure out, hey, can I use the sum or difference of perfect cubes, is figuring out, are these perfect cubes? So, do we have something that is the cube root of 125? Well, yes. That's just going to be 5. If you were to cube 5, you would get 125. So we're going to put that in parentheses and put a cube on the outside. Next, we have a difference here because of subtraction. So we put another set of parentheses. And x cubed, we know that that's just going to be an x in here. And if we have this setup, what's our formula supposed to look like? Remember, sing more songs while washing with soap. So we have our 2 sets of parentheses, one big, one small. We put our cube roots here, so AB, and then SMS, square, right? Multiply, and then square. So that's what SMS gives us. SOAP gives us same, opposite, and always positive. So we have our formula. So in this case, our A would be 5, and our B would be X. So if we plug in our A and B into our formula, we get 5 minus X. This is going to be a 5 squared So let's just write 5 squared to kind of keep things consistent, and then we'll just simplify it a little bit later. Plus 5x plus x squared. And what is 5 squared? Well, that's just going to be 25. So we rewrite this, 5 minus x, 25 plus 5x plus x squared. So now you see how we can use our difference of perfect cubes to factor this. Remembering our formula gets us 90% of the way there. But we got to remember the order. Remember, sing more songs as you wash with soap. Sing more songs, square multiply square, same, opposite, always positive. Same, opposite, always positive. Well, I hope you were able to follow along with today's example. Remember, sing more songs while washing with soap will get you about 90% of the way of remembering which formula to use whenever you have a sum or a difference of perfect cubes. If you have any questions about what you saw here today, feel free to put them in the comment box below. I'd love to help you out as much as I can. If you have questions about your own homework you'd like to see on this channel, feel free to visit me on Facebook at Tutor Sempai and tell me all about it there. If you found this video helpful, remember to leave a like, it really helps the channel. And while you're at it, hit the notification bell, smash the subscribe button, and share with a friend who can also use the help. Well, that's all the time I have for today. I really hope this helped with your homework, and I'm looking forward to seeing you again next week. I'm Courtney, and this has been another session of Tutor Sempai.